Hi guys, welcome to Piece of Code and welcome to this video. In this video, we are going to see all you need to know about serverless technologies on AWS. So just by going through this video, you will master all of the serverless technologies on AWS, and also you will be able to answer all of the questions which will come from this particular section in the AWS Solutions Architect exam. So without wasting much time, let us just dive into this topic, which is serverless on AWS. Let us understand what serverless means, right? So serverless is a new paradigm in which the developers don't have to manage servers anymore. You just deploy the code, and in a very productive manner you can just deploy functions, right? So serverless means, initially what it meant is functions as a service. It means that you just write some code like your function and basically just write some code, and basically that's it. That's all you need to do as a developer. Initially it was like that. Still you can write functions by using the Lambda functions or something like that, but there are also other services which are serverless also. So serverless was pioneered by AWS Lambda, but it also includes anything that is managed like databases, messaging, storage, etc, etc. Serverless does not mean there are no servers. Obviously you will need servers to run the code in a web server, right? You need servers, you need some kind of physical hardware. But the thing is, you do not have to care about the allocation of that hardware, or where is that hardware, or to provision that hardware. You don't have to worry about all this stuff. It is all going to be taken care by AWS, right? That's all it means about serverless. Serverless doesn't mean basically there are not servers. If there are no servers, where will the code run? Will it run on the cloud literally? No, it's not the case, right? It will run on servers, but you don't know about the servers, right? That's all it is. Let's move forward. So these are all the services which which are serverless technologies in AWS. One is AWS Lambda, which is one of the most popular serverless technologies on AWS, right? Then we have DynamoDB, most popular, you can say, database technology, serverless database technology on AWS. Cognito, then API Gateway, S3, then SNS and SQS. SNS stands for Simple Notification Service, and SQS stands for Simple Queue Service. Then there is a data firehose for data analytics purposes. Then there is Aurora Serverless, Step Functions, and Fargate. We are going to see most of these services in this particular section. All right, let's move on to the next slide. For some services like S3 and, for example, Kinesis, we are going to create a separate video. I'm going to create a separate video to know that in detail, but we are going to cover all these services in this particular video at a high level, and some of the services in detail also. Okay, what is AWS Lambda? Why it is so popular? So let us get a comparison between EC2 and AWS, right? So EC2, what are these things? So virtual servers in the cloud, right? You're just going to create a server on the cloud, limited by RAM and CPU. You are going to see how much RAM and CPU are going to provision for your server. You are going to be the judge of that, right? Then it is continuously running. You can on actions, you can either stop, terminate, hibernate, and do these kind of stuff. But the thing is, it is still running. Even there is no code which is running on your EC2 instance, but it is still running. The EC2 server is actually running, even though you are not using it. That's what it means. But you can also do all these operations to actually cut your costs, like stop, terminate, or hibernate your instance. Scaling means intervention to add or remove servers, and that scaling action is also going to be done by you, right? You have to define certain scaling policies, dynamic scaling policy, and everything. Everything has to be managed by you. But what about Lambda? These are virtual functions, no servers to manage, limited by time, short executions. It means that whatever function or code you are going to write, that is meant to be for a short interval of time. You cannot write a whole millions of lines of code for your entire application. That is not the purpose of Lambda. You can use some other service for that. But if your code is very short, it has a short kind of application, then you will use Lambda. You're going to see some examples of short applications. You're going to get why Lambda is going to be the best choice for those kind of applications. Run on demand, it means that you're only going to be charged when you're going to run your code. That's it. Scaling is automated. Don't have to worry about the scaling actions or the policies or anything. You just write your code. Benefits of Lambda. First is easy pricing. As I've already told you, you pay per request. It means that you're going to pay for the compute time, the time for which your particular code runs, and the request that you make to your Lambda function. Free tier offers about instance hundreds, 1,000, 10,000, lakh, 10 lakh, or 1 million. So 1 million AWS Lambda requests are free. So you can actually, do all the stuff for free if you are going to go in the free tier. You are not going to cross a million requests in 2 or 3 days, right? It takes a lot of time to cross that, and you're going to get about 400,000 GBs of compute time, or 4 lakh GBs of compute time. It is very, 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 very much. Don't have to worry about running out of compute time. Integrated with a whole suite of services. You can integrate with a lot of services. You're going to see that in a minute. Many programming languages are supported: Node.js, Java, JavaScript. Whatever you want to run, you can run it, right? No issues in that. Easy monitoring using AWS CloudWatch. Easy to get more resources per function. So you can get up to 10 gigabytes of RAM. Increase RAM will also improve CPU and network. So you, in a nutshell, you are getting a lot for a very less price, very, very less price. And if you're going to talk about the language support, as I've told you, it supports Node.js, Python, Java, C#, Golang, PowerShell, Ruby, custom. If you want to go for a runtime API, a custom runtime API, then you can also go for that. You can also use a Lambda container image, small Docker container, you can just say, or Docker image. It is also supported by Lambda, but it is not good to use Lambda for Docker images, I would say. For that, you can go for ECS or some other stuff. There is also something known as Fargate, which is also a serverless service. If you have any kind of Docker service, you can just go for that. That will be the good alternative. But regardless, you can use it. And if you want to code in any of these programming languages, you can go with Lambda. Right? Cool. Let us move forward. Integrations, and as I've told you, right, Lambda integrates with a lot of services, and these are some of the main services or the most important ones which you need to know for the exam. It integrates with API Gateway, and we are going to see an example with for this integration with API Gateway. It integrates with Kinesis, right? Kinesis data firehose and Kinesis data streams. Then we have DynamoDB integration, S3 integration, CloudFront integration, CloudWatch events, Event Bridge. We are going to see Event Bridge in a separate video. Then it also integrates with CloudWatch logs, SNS, SQS, and Cognito. So these are all the services which Lambda integrates with. Okay. Now talking about an example of integration with S3, right? So this is an example where, for example, you have a S3 bucket, and the name of this S3 bucket is image bucket, right? So you upload images into your S3 bucket. So you uploaded this beach image into your S3 bucket. So what is the action that you are doing when you are uploading an image? You are doing a put object action on your S3 bucket. So this put object action can be a trigger for a Lambda function. So any kind of action that you do on an S3, you can trigger a Lambda function for that. And that thing also can be done using S3 event notification, because put object, get object, delete object, all these things are events which is happening in your S3 bucket, and you can trigger certain based on your events. So you can trigger a Lambda function based on a put object event. Okay, so a Lambda function will be triggered, and the job of that Lambda function is to create a thumbnail of that image. It means a thumbnail is just a short version of this image, right? You just reduce the resolution and everything, and you create a very small image. And then what you can do is you have some logic which will push the image into another S3 bucket, that thumbnail bucket. You can name it as a thumbnail bucket, and it will contain the thumbnail image. And there is also another logic where you can store the metadata in DynamoDB, right? So this is also another thing you can do using Lambda functions. So basically you trigger a action on a Lambda function, right? You trigger a Lambda function directly from using S3 event notification, basically S3 event notifications. We're going to cover this in detail in our S3 video, but for now just understand that any event that happens on a S3, you can trigger a certain action, and Lambda is one of those actions. Okay, cool. I hope that is understandable. All right, let's move forward. Okay, this is another example. So in Event Bridge, you can create a cron job, right? What is a cron job? Basically, it's a script which runs at a specific interval of time, right? So you can create a cron job which will run every 1 hour, and every 1 hour a Lambda function will be triggered, right? For example, every 1 hour you're sending some kind of a systematic email to your clients. You can create a cron job for that, and your Lambda function will send a SNS notification, and that SNS will send an email, right, to the subscribed clients, right? Because in SNS you can create topics, and people can subscribe to your topic, or any kind of service may subscribe to your topic. So that Lambda can trigger an SNS, a simple notification service, and you can send an email. That can be a cron job. So this is an example of a cron job. You can create anything as a cron job. You can just create a script. That's it, right? Pretty easy to understand. Okay, so Lambda pricing example, right? Lambda pricing example. Let us see an example of Lambda pricing. So pay per calls, as I've told you, right? And first 1 million requests are free, and then after that $0.2 per 1 million requests, and thereafter this much per request. So see, it is, you can just understand that the cost is very, very less. And then pay for duration, 400,000 GB seconds of compute time per month for free, which is equivalent to 400 seconds if function is 1 GB RAM, and this much seconds, which is I think 32 lakh seconds if function is 128 MB RAM. So based on your RAM, your compute time may vary. If you are using less RAM, you are getting more compute time, and basically you don't have to use 1 GB of RAM for short executions of your Lambda function. 128 MB or 256 MB will also do. After that, there is $1 for 600,000 GB seconds. So basically you are spending like minimal or negligible money for what you are actually getting. Okay, so let's see an example of Lambda function, and then we are going to move on to the next topic. All right, so let us see an example right away. Let me go to my console now. Okay, so let me go to my AWS console. Let me sign into my console. Okay. All right, we are in our console now. Now let me go to the Lambda functions. So let me just go to Lambda, and you can just directly type Lambda, you will get that. Okay, so yeah, so this is the page that you will receive for the Lambda functions. Currently I do not have any function, right? And so you can easily create a Lambda function by just clicking on create function. So I'm going to use a blueprint. You can create a function from scratch. Basically you will write your own code from the beginning, but I'm going to use a blueprint for that, and I'm just going to create a hello world function. Actually you can create there are blueprints for a lot of different specific purposes, like if you want to, for example, get an object, get S3 object, or do some other stuff, you can just select that. But for now I'm just going to select a hello world function which has a runtime of Node.js 14. I'm just going to name this function as example function, right? And I'm just going to say create a new role with Lambda permissions. Okay, this is what you are going to see if you do not have a role. I may have a role. I have a role like the example Lambda role, this one, but I'm going to create a new role so that you guys don't get confused, right? So a role is basically a default role is created for this Lambda function, so that the Lambda function will write some logs into CloudWatch logs, because you need permissions to write into your CloudWatch logs, right? So a basic role has been created for this Lambda function so it can access CloudWatch. right? Because you need permissions to access a service in AWS, right? And if a service wants to access another service, the best way to do it is using roles. That's why we need an execution role for this Lambda. For example, your Lambda also accesses S3. Then you need to add permissions in your role, in your execution role, for your Lambda function to be able to access S3. And in your S3 also, you need to create a bucket policy which allows that particular Lambda function to access S3, that particular bucket. So it's kind of a two-way relationship going on. Always remember that if you want to access another service in AWS, you need required permissions. That is why we need a role over here. Don't get confused, guys. Create a role, that's cool. Create that function, very easy. Just click on create function. It will take a minute to create the function. It's actually really fast. I think it is done already. Successfully create the function. You can change its code and configuration to invoke your function with a test event. Okay, cool. So this is some code over here. I hope you can see this code. I'm just going to magnify it for a bit. So it just says it accepts some event and a context, right? Don't worry about all these things. So some data is being sent in the event, and that data is coming as key 1, key 2 and key 3. You can just imagine this as a normal JSON object. Yeah, JSON object, right? So basically just consider this, for example, there is a JSON object, and basically it has 3 attributes, key 1, key 2 and key 3, and it has contained some data, right? And we are just fetching that data from here. Value 1, value 2, value 3 equals to event.key1, event.key2 and event.key3, like this. And then if you see over here, we are just displaying it using console.log statements, which are just basic display statements in JavaScript, right? Very basic syntax. That's what it is happening over here. And then we are just returning event.key1. We're just returning one of those values. This is the simple function. Now let us do one thing. Let us test the function. So we are going to create a new event, or it is also known as a test event, where we are going to test the function. We're going to see what happens when our functions return something. We're just going to check, or like a unit test or something like that. I'm going to take this event. I'm going to give it an event as example event, and just keep it private. So as you can see, this is a normal JSON object, right? And if you pass this value, key 1 as value 1, key 2 as value 2 and key 3 as value 3, we are going to get some data on the screen, right? That those console.log statements should display value 1, value 2 and value 3. Simple as that. And we're going to save this, right? And we are going to just test the event. So this is the execution result, and the response that we are getting is value 1, because if you see, we are returning event.key1 and key 1 has the value 1, right? And on the console.log statements, these are the outputs that we are getting. Value 1 equals to value 1, value 2 equals to value 2 and value 3 equals to value 3, because this is the value for key 1 and key 2 and key 3, right? According to that JSON object. So cool, that is how you can create a Lambda function in AWS. That's it. Pretty easy and pretty cool, right? Okay, let us move forward. Okay, now let us go back to our slides and let us continue our theory. Okay, so we're done with Lambda pricing. Let us move on to Lambda limits, and you need to know per region, right? So you need to know these things for the exam. Don't have to remember everything, just need to have an idea of how the Lambda limits and stuff works, right? So execution, if you see, memory allocation 128 MB to 10 GB, and it goes with 1 MB increments. Don't have to worry about that, everything is done in the background. But this is how the limit is up to 10 GB of RAM, and we have already seen this. Maximum execution time is 15 minutes or 900 seconds. As I've already told you that Lambda functions are for shorter executions, right? If you have a particular application which has a shorter execution time, then you can use a Lambda function for that, right? So maximum time that a Lambda function can execute is for 15 minutes, right? Then we have environment variables. Environment variables are just some data that you use during the runtime, right? For example, you can have an environment variable which is region, and basically region is dev, right? So basically you can have multiple alias for your Lambda functions. It is possible to have that. You can have alias for your dev region or your production region or your UAT region, and you can keep certain values there, like region is dev or UAT and or production. Based on your environment variables, you can have certain difference in logic. So you can use those environment variables for those purposes, not only for this particular application, but it can be for various other purposes also, like storing database credentials. It is not safe to store the database credentials like this, but I am just giving an example, right? Disk capacity is in the function container 512 MB to 10 GB. That's much. Basically, it's a small amount of persistent disk you will get that can be up to 10 GB only. Concurrent executions, like simultaneous executions, can be 1000. It can be increased if you contact the support, AWS support. Then deployment, Lambda function deployment size is maximum of 50 MB. Compressed zip, right? You have to zip it and upload it, 50 MB. Size of uncompressed deployment, code plus dependencies can be up to 250 MB. Can use the /temp directory to load those files at startup. And this is a very good question. It can come in the exam. How will you reduce the startup time of your Lambda function? So your Lambda function is of 200 MB and it contains codes plus dependencies, right? How will you reduce the time? Because whenever a Lambda function is starting, it fetches that dependencies and it has to download all those dependencies, right? And it will take some time. How will you reduce that? You can just say that you can store that particular dependencies in your function container or your disk, which is /tmp. So it will directly get the particular dependencies from that particular place and it actually reduces the startup time. It will be one of your options in the exam. Environment variables is 4 KB. We have already seen this. Okay, let us move forward. Customization at the edge. And if you have seen my CloudFront and that global accelerator video where I have talked about caching at the edge, then you have an idea about edge locations. What happens at the edge locations? So at edge locations, to give you a simple idea, at the AWS has a lot of edge locations, 200 plus edge locations there are there, and at each edge locations you can cache your data so that people which are in a close proximity of your edge, they can get the data at a higher speed, because obviously the data is cached to a nearest edge location. For example, I am in India and the nearest edge location to my location is Mumbai. So any data that is coming, if you have configured edge location caching using CloudFront or something like that, the data will be stored at the Mumbai edge location, and the next time when I'm fetching the data, I'm going to get it from that particular edge location, which will be much faster. Latency will be reduced. That's all about the edge locations. And that's what it says in this particular thing. Many modern applications execute some form of logic at the edge. So what is the edge function? It is kind of related to Lambda functions. A code that you can write and attach to CloudFront distributions, right? It will run at the edge, you can just say. So it runs close to your users to minimize latency. Because as I've told you, right, I am in India and the closest edge location is Mumbai. So that the function will run at that particular Mumbai edge location to minimize the latency. CloudFront provides you with two types of functions. One is CloudFront Functions and Lambda at the edge, or Lambda @edge. You don't have to manage any servers. It is deployed globally. Use case, customize the CDN content. Right, your content or your data is being is actually cached at the edge, right? You want, before fetching the data, you want to do some customizations. You can do those customization using a Lambda function at the edge or a CloudFront function. Pay for only what you use, like Lambda functions, and then it is fully serverless, right? Let's move on. CloudFront functions and Lambda @ use cases. Let us talk about this. So for website security and privacy, dynamic web application at the edge, right? You want to alter some data before fetching the data by the user. You want to alter that thing. Search engine optimization, intelligently route across origins and data centers. You want to change some routes before the data is being fetched or it goes to a certain destination. Bot mitigation at the edge, you can check if the particular data that is being fetched from your edge location, is it a bot or is it a regular person. Your lambda function or your lambda at the rate edge function can contain some logic which will test if the particular thing that is accessing your data, I am saying thing because it can be a bot or it can be a person, right? So you can just write some logic like a lambda function which will check if that particular thing is a person or a bot. Real-time image transformation, you can also do some image transformation stuff at the edge. A/B testing you can do at the edge. User authentication and authorization, like before accessing the particular data you can authorize, you can just use the authentication logic which will authenticate the user. User prioritization, user tracking and analytics, anything that you want to do before the data is getting fetched from your edge location or before the data is being uploaded to the edge location, that's where your lambda function is going to be, you know, integrated, right? Pretty simple stuff, don't have to worry about all these things. Just remember these things for the exam. Don't try to memorize everything, just try to understand what I can do with a lambda at the rate edge function. What can I do at an edge location, for example? Just try to put yourself in that particular position and you're going to get an answer, right? Cool stuff. Okay, let's talk about CloudFront functions in detail actually. Now these are lightweight functions. Now remember the keyword over here, these are lightweight functions and they are only written in JavaScript, right? So this is an example of a CloudFront function. Let us first read all these things, right? For high scale latency sensitive CDN customizations, it is used for that. Sub millisecond startup times, millions of requests per second it can handle. Used to change viewer requests and responses. Viewer request, what is a viewer request? After CloudFront receives a request from a viewer. Viewer response is just the opposite of that, before CloudFront forwards the response to the viewer. Native feature of CloudFront, manage code entirely within CloudFront. So basically what is happening is that this is your origin server, it can be S3, right? And the origin interacts with the CloudFront, right? Some data goes into the CloudFront edge location and the data is being stored at the CloudFront edge location. So don't worry about the origin and request and response, right? Origin request is basically CloudFront is requesting some data to the origin, and origin response means origin, that is S3, is getting back to CloudFront with some data. That's it. We don't have to worry about these things because CloudFront function do not deal with origins request and response. It deals with viewer request and response. Who are the viewers actually? The client or the users? So you can actually manipulate with the viewer request and viewer response, which is basically a user's request to the CloudFront edge location. For example, the client is requesting some data or a image from your edge location. You can manipulate with that request which is coming from the viewer, and you can also manipulate the response which goes back from the edge location to the user, like that image. You can, for example, before sending the image, you reduce the size of the image from 5 KB to 1 KB. You can do that using a CloudFront function, but you cannot actually deal with the origin request and origin response, right? And you can ask a question, what if I want to manipulate with the origin request and response? What if I want to manipulate the data that is coming from S3? Can I do that using CloudFront functions? No, you cannot do that using CloudFront functions. If you want to manipulate the request of the origin and the origin request and response, you have to use lambda at the rate edge functions, which are going to see in a minute. Lambda at the rate edge functions. So these are pure lambda functions. CloudFront functions are managed within CloudFront. Lambda at the rate edge functions are pure lambda functions. You are going to create them like you are creating the lambda functions, like we just saw an example. So lambda functions written in Node.js or Python, right? You have to write in these two languages. And these are actual lambda functions. Scales to thousands of requests per second. Used to change the CloudFront requests and responses, which is the viewer request, origin response, and viewer response. So you're going to change all these four of these things. You can manipulate the client's request and response, which are the viewer request and response, and you can also manipulate the origin request and response. So if your use case is to deal with origin request and response, then you can use Lambda@Edge functions. Okay. And one thing you need to keep in mind is that author your own functions in one AWS region, which is US East 1, then CloudFront replicates it to its locations. As I've told you, right, CloudFront is a CDN, content delivery network, and it caches your content at the edge for faster delivery of your data. Similarly, you just have to write your function at one place, and CloudFront will take care of just taking your function and just spreading it over the world. It takes care of that. That's how efficient CloudFront is, right? Okay, now let us move forward. I think this thing is enough explanation. If you have any doubts, you can just put it down in the comment section. I will be able to answer them. So that is the Lambda@Edge. So try to understand the difference between CloudFront functions and Lambda@Edge functions. Lambda@Edge functions. As I've already told you, the runtime support for CloudFront functions is JavaScript, Node.js and Python over here, right? Triggers, viewer request and response. It covers both viewer request and origin request and response. Execution time is less than 1 millisecond. If you want faster execution and you are only dealing with viewer request and response, then please go with CloudFront functions. And Lambda@Edge functions will take the normal execution time of your Lambda function, which is 5 to 10 seconds. Maximum memory or RAM is 2 MB for your CloudFront functions, but it is 128 MB to 10 GB for your Lambda@Edge functions. It is the same for the Lambda functions, right? For Lambda functions, we saw the range for the RAM is 128 MB to 10 GB. Similarly, for Lambda@Edge functions, it is the same, 128 MB to 10 GB. Total package size is 10 to 10 KB. Normal Lambda functions like 50 MB, right? For your, as a zip file, you upload your Lambda functions, which is up to 50 MB. Similarly, for Lambda@Edge functions also, it is 1 MB to 50 MB. Network access, file access, nothing, but here you can go that. Access to the request body, not possible. It is possible for this thing. For pricing, CloudFront functions have a free tier available, and it is 1/6 the price of Edge. And for Lambda@Edge functions, you have no free tier, charged per request and duration. So basically, in a nutshell, if your requirement is like faster execution, less cost, and you only are going to deal with request and response of the viewer, and it can handle millions of requests per second, basically very less latency, then please go with CloudFront functions. The only possibility for using Lambda@Edge function is when you are going to deal with origin request and response. I think that is the only place where the exam will ask you to answer Lambda@Edge, but all other times it is always good to choose the CloudFront functions because it is cost efficient, and also if you have a very less things to do, then basically it is CloudFront functions. All right, that should be it. Let's move on to the next slide. So use cases, I think it is very easy to understand. CloudFront function is cache key of normalization, transform request attributes, headers, cookies, query strings, URL to create an optimal cache key, right? So it only deals with viewer request and response. If you want to manipulate the request headers, query strings or URL of the viewer, then you can use CloudFront functions for that. Header manipulation, same thing like that. URL rewrites or redirects, we have already seen this. Request authentication and authorization, right? If you want to authenticate a request coming to the edge, you can use a CloudFront function for that. Lambda@Edge, longer execution time, several milliseconds, 5 to 10 seconds, we have already seen this. Adjustable CPU or memory. So basically, if you want more customization, and also you want to deal with the origin request and response, then please go with Lambda@Edge. Otherwise, always go with CloudFront functions. Okay. Now, Lambda by default. What does this mean? By default, your Lambda function is launched outside your own VPC. Don't worry about VPC. We are going to cover VPC in depth in a separate video. So VPC stands for Virtual Private Cloud, which is basically your own network on AWS or on the cloud. Whatever cloud service provider you are using, you can create VPC in any cloud service provider. So what it says is that your Lambda function is launched outside your own VPC. That is why your Lambda is being able to access all other services, and also it can access the public internet. But if you want to access a private RDS instance in another VPC, private means it has only a private IP address. It doesn't have a public IP address or a public DNS. It has a private IP address, and it makes sense, right? How will you access a particular device which doesn't have a public IP? Just the same logic. So if your Lambda is public, it is not in the same VPC or in the same network. Let's talk about networks. Let's not say VPC, you will get confused. Let's say networks. If your Lambda function is not in the same network, how will it access the same RDS instance which is in this network? Right, therefore it cannot access resources in your VPC. It can only access whatever is available on the public internet. That is what Lambda by default means. Whenever you create a Lambda function, it is launched by default outside of your VPC. But it's not that you cannot launch it in your VPC. You can launch it in your VPC. How can you launch it in your VPC? You must define the VPC ID, the subnets, and the security groups. Lambda will create an ENI, which is Elastic Network Interface. We have basically, I'm going to discuss Elastic Network Interface in a separate video, what it means. But Elastic Network Interface is basically, in common layman terms, it means that each particular device is associated with a network interface, and that network interface can have private IPs and public IPs. So if you want your device to have a public IP or a private IP, you need to have a network interface attached to it. That's what it means. So if you define the VPC ID while launching your Lambda function, then basically an ENI will be created, which will be associated with your Lambda, and then the Lambda will be launched in your subnets. Subnet is basically a group in your VPC. If you see this diagram, then you will get a better idea. This is your Lambda function. So an ENI is being attached to your Lambda function, and you are launching it in your security group, for example, right? Because it should be attached with a security group, Lambda security group, you can say. And it is in a private subnet. And there is a RDS instance, and this Lambda function needs to access this RDS instance. Simple as that, right? This RDS security group must allow incoming SQL connections from this Lambda security group. If it allows that, then basically you can access this RDS instance. Simple as that. So basically you need to define the VPC ID, the subnets, and the security groups while launching your while launching a Lambda in your VPC. For that you need to have your own VPC. For now we have not known how to create VPCs, so just to wait. You don't have to remember this thing or create this on your own. That's why I'm skipping this part of creating the VPC. We're going to see in the VPC chapter how you can create your own VPC, and you can launch whatever you want in your own VPC. So just wait for it. Alright, so let us move on to the next topic. Lambda with RDS Proxy. Now what is an RDS Proxy? Let us first understand that, and we are going to cover RDS Proxy in details in our databases video later on. Just understand that you have a RDS instance. RDS is a relational database service on AWS, right? And if you have a lot of connections coming into your RDS database instance, then what happens is that, so for example, there are a lot of connections coming into your RDS instance, millions of connections or hundreds of connections. So a lot of pressure will be there on your database instance because it is accepting a lot of connections. A lot of services are trying to access your RDS instance at once. So to deal with this issue, you create a RDS proxy. This proxy that you see over here. So none of the connections you are going to connect to your RDS instance directly. Instead of that, they will go through a RDS proxy, and this proxy will forward the particular whatever traffic is coming in to your RDS DB instance, relational database DB instance. So basically your RDS instance doesn't need to deal with all of those connections directly. For example, you have a ton load of Lambda functions, and all those Lambda functions, for example 200 Lambda functions are accessing this RDS instance, right? So you can create a RDS proxy, and basically a Lambda function will go through that RDS proxy to your RDS DB instance. That's what it means. So it can improve availability by reducing 66% of failover time and preserving connections. That's what I told you, right? If the load on your RDS instance is more, then basically you will have more failovers. Basically more and more services will not be able to connect to your RDS instance. So by using the proxy, you reduce it by 66%. And also you can enforce IAM over here, and basically if a particular service doesn't have a particular permission to access your RDS proxy, then it cannot go through. Lambda function must be deployed in your VPC because RDS proxy is never publicly accessible. So you have to create your own VPC. If your RDS instance and your RDS proxy in a private subnet, then your Lambda function must also be in that VPC, so that they will be able to access your RDS proxy, right? Simple as that. So I think that should be enough explanations. Let us move forward. All right, we are going to start with DynamoDB right now. Okay guys, let us see Amazon DynamoDB, right? So it is a fully managed, right, highly available, just see the key points, right, with replication across multiple AZs, NoSQL database. It is not a relational database with transaction support. So it has transaction support. Transaction mean it can support ACID properties, which is basically prone to that, which basically corresponds to the relational databases. It has transaction supports. It scales to massive workloads, distributed database, millions of requests per second, trillions of row, hundreds of TB of storage, fast and consistent in performance, single digit millisecond latency, integrated with IAM for security, authorization and administration, obviously that is common for most of the services, IAM security, low cost and auto scaling capabilities, no maintenance or patching, always available, and it has standard and infrequent access table classes. So basically if you want some kind of NoSQL databases which scale seamlessly according to your needs and you don't have to manage anything, so you can directly go with DynamoDB, and you get a fair share of questions in the exam, in the solutions architect exam actually, but you won't get in-depth questions as you get in the developer associate exam from DynamoDB, but still you will get some questions from the DynamoDB section. So let us get into it a little bit more. So let us talk about some basics of DynamoDB. DynamoDB is made up of tables, right? Like relational database, it is also made up of tables. Each table has a primary key and it must be decided at creation time. Okay, I'm going to show you a demo on DynamoDB and then you're going to understand what does this mean. Basically each table must have a primary key, and that is true for relational databases also. Each table can have infinite number of items, or if you're going to compare it with the RDBMS, then it is a rows, right? You can have infinite rows, and each item has attributes which are basically columns if you're going to compare with the relational database like this. So you have columns like this one, so these are all your attributes and the rows are your items, right? That's how you can compare with a relational database. Maximum size of an item is 400 KB. It doesn't mean that the maximum size of the table is 400 KB. It means that each single item can be 400 KB. That's what it means. Data types which are supported are string, number, binary, boolean and null. Okay, it also supports document types which are list and map. So it also supports complex data structures also like list and map. Set types also like string set, number set and binary set. Therefore in DynamoDB you can have rapidly evolving schemas. So basically in NoSQL databases your schema is actually really flexible, like in MongoDB, right? You have a document data structure. Similarly in DynamoDB we have a different kind of structure, and you can have flexible schema. That is why if your schema changes at a certain period of time, or it is in very flexible, right? You don't have a fixed schema, then DynamoDB is the answer for you guys. So always ask yourself questions: do I need this thing or do I do not need this thing, right? If you get your answer, then that is your actually answer. If you have asked questions to yourself and you come to a conclusion that DynamoDB is the answer, then basically that is your answer. But while answering those questions, please consider all the facts that you have learned. Don't go for wrong facts. Always consider what you have learned, the right facts, right? Okay, now DynamoDB table example. So there is something, so we have talked about the primary key, right? And we have said that okay, the primary key must be decided when we are creating the table, the DynamoDB table. But okay, what is this sort key actually? And if you appear for the developer associate exam, you actually have to learn a lot about the sort key and the partition key. But keep in mind, you can compare this combination of partition key plus a sort key to something known as a composite key in relational databases, right? So you can have multiple keys which corresponds to a particular primary key. Now if you're going to try to understand in depth, then partition key is actually the very unique key which should be in your table, like this user ID. There is another sort key. For example, you want to sort your items in your table based on a particular attribute like the game ID, then you can keep a sort key for that purpose. But the sort key doesn't always used for sorting purposes, it has other purposes also. But to keep things simple, just understand that sort key is basically used for sorting purposes. Basically you can sort by that particular key, and you can use the combination of a partition key and a sort key to actually query your table or scan your table. So these are two things by which you can actually extract data from your table, query and scan. And if you have partition key and sort key, you can use both of these keys to query or scan your table, basically extract data of your table. You can also use for sorting purposes also, right? So as I've told you, the partition key and the sort key corresponds to a primary key. Remember that the sort key is not you don't have to create the sort key every time. It is not mandatory to create, but you need to create a partition key while you create the table. Okay, that is what we mean by a primary key. And these are other normal attributes like the score and the result, like this table, right? Pretty easy to understand, guys. Now let's talk about read-write capacity modes. What does this read-write capacity modes mean in DynamoDB? So control how you manage your table's capacity, read, write, throughput, right? Like basically you will read from your table and you are going to write into your table, right? So basically there is some kind of capacity associated with your read and writes. So there are two types of capacity that you can go for in DynamoDB. One is your provisioned mode, and which is basically your default mode, and another one is on-demand mode. What does this provisioned mode means? You specify the number of reads and writes per second. You're going to say, okay, I need 2 KB of reads and 2 KB of writes per second, and that much capacity is going to be provided to you for your DynamoDB table. But the thing is, you need to plan the capacity beforehand. For example, if at a certain peak level of your application, that particular threshold that you have specified, 2 KB, is getting exceeded, so there will be a lot of latency associated with fetching or writing into your table. So if you know that, okay, that my read capacity and write capacity will be constant for this period of time, then you can go for this provision mode. Basically you are going to give the units as read capacity units and write capacity units. I told it in KB, but basically you are going to give it in RCU and WCU. You are going to specify, okay, I need 2 RCU and 2 WCU, right? 2 read capacity units and 2 write capacity units. The exact volume of how much data can be transferred and extracted in these read capacity units and write capacity units, you don't have to know about that, because that is out of scope for the exam. That is in scope for the developer associate exam. You also get questions like if you have data about of 1 MB and you have specified 4 RCU and 4 WCU, so how much time it will take to transfer this amount of data into your DynamoDB table? This kind of questions may come in the developer associate exam, but it doesn't come in the solutions architect exam. So people who are actually going for the developer associate exam, I'm going to create another separate video for DynamoDB itself, it will be beneficial for developer associate guys. But for solutions architect guys, this video is completely enough to cover your serverless architectures syllabus. Okay, so that's it guys about the provision mode. Now on demand mode, as the name suggests, right, you don't have to worry about your read capacity units and your write capacity units. Basically it will be taken care by the DynamoDB itself. If your need goes high at some point, then it will automatically increase your RCU, and when it is at the lowest, then it will automatically decrease. But the thing is, pay for what you use, it is more expensive, okay, because it is going to be managed, right? It is great for unpredictable workloads, steep and sudden spikes, right? If you don't know what is happening, what is your particular capacity is, then it is better to go for on demand mode. Now guys, let us see an example about DynamoDB. Let us see how we can create a DynamoDB and stuff. Okay, so I am in my AWS console. Let us search for DynamoDB. So just click on here. Okay, so we are here. You can just go to tables directly. I do not have any tables, so I can just create a table right now. Create table. Just going to name it as this table as artists table. For partition key, let us name it as artist name underscore name. So basically this will be my partition key, so kind of my primary key. So there is a optional sort key. You can create a sort key while creating the your table also. Let us create a sort key, which is optional, but still let us create it. I'm going to just name it as rating will be my sort key. So let us see customized settings, and let us see some of the options. We are going to go for the default settings, but let us see some customized settings so that you will understand what are the configurations that you need to do. So here there are two modes, DynamoDB standard and DynamoDB standard IA. So it says that the standard mode says that the default general purpose table class recommended for vast majority of the tables that store frequently accessed data with throughput, reads and writes as the dominant table cost, right? So it is a general purpose table. Infrequent access, as you can compare it to the infrequent access of the S3, right? S3 storage class. So it is recommended for tables that store data that is infrequently accessed with storage as the dominant table cost, right? So we can just compare. If you are infrequently accessing the data, you can go for this one. So you can just see the capacity calculator. You can calculate how many read capacity and write capacity you want. So if your average item size is, for example, 200 KB, and item read per second is, for example, 2, so and item write per second is 1 unit, then you need 50 read capacity units and 200 write capacity units. And it also makes sense because you are reading you can just say 2 units per second, right? So if you take 50 read capacity units, then basically you will be able to achieve that, but you are actually reading only 1 unit, so you'll need 200 write capacity units for this thing, for an average item size of 200 KB. Don't have to worry about this thing, it is for the developer associate stuff, so just leave it. Provisioned capacity will select, and auto scaling will keep it as off. So let us take the provision capacity units as 1. Let us keep it at the least. We don't want any secondary indexes. Write capacity units, we'll take it off, and we're going to take only 1 write capacity units, and estimated read write capacity cost this much. And yeah, let's keep it all as defaults, and let's create the table, right? So it is getting created. Cool stuff, right? So delete protection is off, don't worry about that. So it is getting created. Let me just reload. Okay, this is an active state. So let us go to artists over here and explore table items. So currently we don't have any item. We can create an item. So let us take the artist name, Harry Styles. I'm a One Direction fan and a Harry Styles fan, so I don't know. artist name, and then let's say rating is, for example, 9, and add a new attribute. You can add new columns or attributes into your table. Just say song name or song, you can just say, and song name, and let us say as it was. Okay, now we can create the item. Okay, you can create another item. For example, the artist name is The Weekend, rating is 9.5, for example. Add a new attribute string, and let us give the song name as Blinding Lights, right? Create an item. Cool stuff. So currently I have 2 items in my table. So this is how you can create items in your table, and you can actually query and scan items from a table. Actually, there is a difference between scan and query in your table. So let me just give you a brief detail about scan and query. So what happens in scan is, if you are going to search for an item using the scan operation in a DynamoDB table, so scan operation actually fetches all the data at once in the beginning, and then if you have a condition, then it extracts the data from the fetched data. To give you a very good example, let me just open up OneNote. So for example, you have a lot of data in your particular DynamoDB table, like a lot of items. So scan operation will fetch all the data. Then if you have a condition like I only want the data with ID 101, then what will happen, from all the data that has been fetched, it will search for this ID 101, and that particular item will be returned, right? But if you are using a query operation, it is actually more efficient, because it will not fetch all the data from the table. So you have the table over here, you query for ID 101, it will only return the item for ID 101. That's it. So I don't think you will get a question between the difference of scan and query. It generally comes in the developer associate exam, but the thing is, query operation is more efficient than scan operation. But let us use whatever. There are only 2 items in the table, so you can just go with the scan operation or the query operation. So this is my table, so I can just select a partition key. I can query based on my partition key, and for example, I will select, all right, and you can also sort by, use the sort key to actually check for that or query a particular item. So if I run this query over here, so I'm getting one item over here, which is Harry Styles, because I have searched for that partition key. So yeah, that's how you create a DynamoDB table. That's how easy it is to create a DynamoDB table. Now you can just go over here and delete the table, and just write confirm over here. I don't want to get charged, so that status is deleting. All right, let us move forward. Now let us talk about some other stuff about DynamoDB. Let me just minimize this thing. Okay. Now DynamoDB Accelerator or DAX, get some questions from this particular section. What do you mean by DAX? It is a fully managed, highly available, seamless in-memory cache for DynamoDB. It helps solve read congestion by caching the data. It has microseconds latency for cached data, doesn't require application logic modification, compatible with existing DynamoDB APIs, and 5 minutes TTL for cache. Simple thing. If you want to compare this DAX with something, you can compare it with an RDS read replica. If you guys know about read replicas and RDS, then it is the same thing, but it is for DynamoDB table. But if you don't know about it, it is just a cache. So what will happen? Your application is going to communicate with your DynamoDB table, but before going to the DynamoDB table, any read operation, it will first go to your DAX cluster, your DynamoDB Accelerator cluster. If that particular data is in here, then it will be returned directly. If it is not here, then it will be fetched from the DynamoDB table. It will write through the DAX cluster and it will be returned to your application. So from the next time when we are querying for the same data, it will be fetched from the DAX cluster. Similar operation of a cache. You can just compare like how a cache operates. This DAX cluster operates in the same way, but it is for DynamoDB, right? Now, DynamoDB Accelerator DAX versus ElasticCache. Now, ElasticCache is also an in-memory cache, but you can use ElasticCache with various other services also. It is kind of a cache. You can use it for as an application cache, as a session cache, whatever you want to use, you can use it, right? But for DAX, that is just for DynamoDB. That's what it is saying. If you want to store aggregation result, then go for Amazon ElasticCache. If you want to store session data or session cache or whatever other, you can also use ElasticCache with RDS also. You can also use ElasticCache with your own application also. If your requirement is huge and it is flexible and you need caching, and another thing, you are okay with heavy code changes, because if you want to use some kind of cache, right, some kind of modifiable cache or a very flexible cache like Amazon ElasticCache, which is actually an EC2 instance, right? It is a server. So you need to do heavy code changes in your application so that your code will first communicate with your ElasticCache. If you are okay with that, and the question also says okay, you are okay with heavy code changes, then you can go with ElasticCache. But your requirement is just to work with DynamoDB and you need a cache, then the answer is DAX immediately. There is no point of going to ElasticCache at all. Let's move forward. Now, DynamoDB stream processing. Ordered stream of item level modifications, create, update, delete in a table. Use cases are react to changes in real time. Like, what do you mean by stream processing? So you have a DynamoDB table like this, right? And it has certain attributes and there are certain items in your DynamoDB table. That's cool. You insert some items. When you insert some items, you want to record that insertion in another table. Now you can have some code in a Lambda function. So whenever an item is added to your table, that Lambda function will get triggered and it will just update another table. You can do that. You can have another DynamoDB table for that. But DynamoDB comes inbuilt with stream processing or DynamoDB streams, and it will automatically record your insertions and deletions if you want it, and that is DynamoDB streams. So if you have any item level modifications like create, update or delete, just go for DynamoDB streams if you want to keep a track of it. Use cases are react to changes in real time, real time usage analytics, insert into derivative tables, implement cross region replication, invoke AWS Lambda on your changes to your DynamoDB table. Like I just told you an example, you can also invoke that AWS Lambda functions on your DynamoDB table. Now, the differences between DynamoDB streams and Kinesis data streams, which is a newer version. You can also use Kinesis data streams for this particular purpose also. But the thing is, Kinesis data streams completely comes under a different service, which is Kinesis, which is basically for data processing. But don't have to dig deeper into Kinesis data streams as of now. I'm going to cover Kinesis in a different video altogether. But if you're going to see some differences between these two services, then DynamoDB streams has a 24-hour retention. Means the stream table that is going to be created from DynamoDB is only going to live up to 24 hours retention. The data will be retained for 24 hours. But in Kinesis data streams, it has 1 year retention. Limited number of consumers. Consumer means what? Whatever service that consumes the data. So DynamoDB has a limited number of consumers, but Kinesis data streams has high number of consumers. We are going to see that in that video itself. Okay. Processing using AWS Lambda triggers or DynamoDB stream Kinesis adapter. Processing using AWS Lambda Kinesis data analytics, Kinesis data firehose, AWS glue. So basically, Kinesis data streams is a powerhouse of ETL tools. Extract, transform, load. That is why nowadays it is preferred more over DynamoDB streams, but it doesn't mean that DynamoDB streams is gone altogether. Okay, so that is the difference between these two things. We're going to cover this in detail later on. Don't worry about that in another video. But for now, Just let us stick to DynamoDB. Now there is an example of DynamoDB streams over here. So application did some create, update, delete into your DynamoDB table, so it is being recorded by DynamoDB streams. It can also get recorded by Kinesis data streams, as we saw, right, because it is a new ETL kind of tool that is very popular. Then we have a processing layer from DynamoDB streams. There is a processing layer, and we have a DynamoDB KCL adapter, and there is a Lambda function which gets triggered when DynamoDB streams some kind of record is inserted over it. From here you can trigger an SNS notification which can send an email. For example, let us take an example, right, that will be better. So you are keeping a track of which user logged in at a particular time in your application, because your application contains a lot of sensitive data. Now when a user is getting logged in into your system, so you are keeping a track of that, right? You are adding that user in a particular table. For example, when you are adding that user in a particular table, a stream gets invoked, DynamoDB stream gets invoked, which invokes another Lambda function. Then that Lambda function triggers a SNS notification. This SNS notification is configured to send an email notification and SMS notification to your subscribers. Your subscribers can be the people in your company's mobile phones or any kind of devices. You're going to learn about SNS later on, but that's it, sending some notifications. That is one of the use cases. You can also do some filtering and transforming, and you can store it in another DDB table. From the Kinesis data stream side, you can pipeline this data to Kinesis data firehose. From data firehose you can send it to 3 destinations. Actually, Kinesis data firehose can send the data to 3 destinations. One is Redshift, one is Amazon S3, and one is OpenSearch. Amazon Redshift is a data warehouse, so you can further process your data in the data warehouse like a OLAP, online analytic processing. You can do that using Amazon Redshift because it's a data warehouse. You can archive the data in Amazon S3, right? You want to store the data for longer periods of time, you can archive it in S3. Or you can do more indexing, more searches using OpenSearch, and it is actually the successor of Elasticsearch. Previously it was known as Elasticsearch. Okay, so this is an example like how you can use DynamoDB streams for a lot of purposes, and you can integrate it with Kinesis data streams also. You can integrate it with SNS also. You can integrate it with from Kinesis data streams you can go to Kinesis data firehose. From data firehose can go to Redshift, S3 or OpenSearch. There are n number of possibilities, guys. The system design architecture is, you can just think about a lot. This is just an example. Okay, so let us move on. Let us talk about DynamoDB global tables. What do you mean by DynamoDB global tables? So make a DynamoDB table accessible with low latency in multiple regions. So basically you have one table in US East 1, you have another table in AP Southeast 2. Basically it has an active replication. It means that whenever a particular change happens in this table, then basically this table also gets updated. So it is a two-way replication. Application can read and write to the table in any region. Must enable DynamoDB streams as a prerequisite. That is a prerequisite. You can compare this with S3 cross region replication, S3 CRR, if you have learned about it. Otherwise we are going to cover this in a separate video in S3 section. Okay, now what do you mean by DynamoDB time to live? Now as the time as the particular suggests, time to live, it's automatically deletes item after the expiry timestamp. So your time actually specifies how much time that item in your table is going to live or going to be retained. For example, you are storing session data, and basically you are allowing your user sessions to be valid for only 6 hours. So after 6 hours you have to delete the session data. You can delete it manually, but that is not feasible. You can specify a time to live. Okay, so they can specify a timestamp like, okay, this number of time this particular item is going to be stored in my table. After that it is going to be deleted, right? That is known as time to live. That's it, right? Very cool stuff. Now DynamoDB backups for disaster recovery. You can do continuous backups using point-in-time recovery or PITR. It is optionally enabled for the last 35 days. Point-in-time recovery to any time within the backup window. The recovery process creates a new table. So basically, if you enable PITR, which is point-in-time recovery, it is optionally enabled for 35 days, and you can go to any time within the backup window. Any time within the 35 days you can go back, and the recovery process entirely creates a new table. Then there is on-demand backups. You'll get full backups for long-term retention until explicitly deleted. It is in your own hands, right? But continuous backups will continuously back up your data, and retention is for 35 days, which is basically similar to other backup conditions also, other continuous backup conditions also, like in RDS and everything. And on-demand backups are actually also same for all kind of services. If you do an on-demand backup, you basically have that retention period in your own hands. If you want to delete it at some point, you can go for that. What are the use cases? You can use on-demand backups for critical save points. It means that there was a massive change in your application data. You can create an on-demand backup for that change, and you can keep it. For example, there is a failure, you can at least roll back to that critical change, right? That is about on-demand backups. A recovery process creates a new table. That's the same for both of these conditions. Integration with Amazon S3 DynamoDB. Yes, it can be integrated with S3 also. So export to S3, it means that you can export your data which is in your DynamoDB table to S3. Works for any point of time in the last 35 days. Doesn't affect the read capacity of your table. Perform data analysis on top of DynamoDB. Obviously, there is a service known as Athena, and using Athena you can directly query a S3 table. S3 data, a bucket, you can just say, like directly. You don't even have to transport the data from S3 to OLAP warehouse like Redshift and then query the data. Instead of doing that, you can directly query the data on S3 using Amazon Athena, right? That is a very cool service. We're going to learn about that later on. And second thing, you can also import data, right, to DynamoDB from S3. It is also possible. Import to S3. Doesn't consume any write capacity. This is very, very important to remember that. Sometimes it comes into the question in the exam that because the data is written into DynamoDB from S3, is it going to take any write capacity because it is going to be written into a DynamoDB table? The answer is no. You are going to save a lot on write capacity if you are importing the data from S3 itself. Okay. And imported errors are logged in CloudWatch logs. So you can also check the logs if there is some kind of failure in importing the data into DynamoDB. Right? Now, an example of building a serverless API. There is a client, there is a REST API, right? And it goes through a API gateway. Your API gateway proxies the request to an Lambda function, and Lambda function does some CRUD operations, create, read, update and delete operations. CRUD means that on your DynamoDB table, right? Simple example, simple architecture. Okay, let us talk about AWS API Gateway, right? And as the name suggests, if you have worked with some API gateways, then you can understand that if you have microservices kind of architecture, then this is your get-go for your gateway, right? So this is a common example, AWS Lambda plus API Gateway, no infrastructure to manage. So basically what I'm saying is your AWS Lambda will contain all your logic, whatever business logic you have, and your API Gateway will be just like a gateway or the entry point to your APIs. Support for WebSocket protocol. If you have some applications working on WebSocket protocol, then you don't have to change it. You can just integrate it with API Gateway directly. Handles API versioning. You can maintain versions of API. So for example, you created an API, then you launched an update of that API, then basically you can maintain versions so that you can roll back to your previous version of API. Very cool feature, and questions come from this particular versioning, right? Handle different environments like dev, test and prod. Handle security, authentication and authorization, right? Create API keys. handle request throttling. Swagger Open API integration is also possible. So basically Swagger and Open API basically are documentation things where basically you have created, for example, 10 APIs and you integrate Swagger with it. Basically what will happen, that Swagger endpoint will contain the details about all of your APIs and what your API does. So it is a very good documentation tool, you can say, and you can easily integrate it with API gateways. It is very popular with Java, Spring Boot and everything. So yeah. Transform and validate requests and responses. You can validate requests and responses. You can use security also, IAM authentication or Cognito integration. You can do whatever you want. Generate SDK and API specifications. You can also use it with an SDK and also cache API responses. There are also a thing about caching. You can also do that. So integrations, you can integrate with a Lambda function, and we're going to see an example how you can integrate with Lambda function. Invoke a Lambda function when an API gateway endpoint is hit. So basically, for example, there is /employee endpoint and it is a get URL, and what you can do, you can integrate with a Lambda function. Whenever someone tries to access this particular endpoint, then a Lambda function will get triggered and some business logic may run. Then you can also expose some HTTP custom endpoints that you have in the backend, like an application load balancer or an on-premise HTTP API, whatever you want. AWS service, it can also integrate with any other AWS service, right? You can expose any AWS API through the API gateway. Example, start an AWS Step function. We're going to see what AWS Step functions are at a high level. And post a message to SQS. SQS stands for simple queue service, right? Simple queue service, and this queue is actually this queue, not the letter Q. Okay. Why? Add authentication, deploy publicly, rate control, whatever you want to do, you can do it. So you can easily integrate with any of the services. Moving forward is an example, say service integration example. This will be very clear. So there is a client and it requests endpoint, for example /employee endpoint, and then it sends some data into Kinesis data streams, then it pipelines it to Kinesis data firehose, and from there we are archiving the data in Amazon S3. See how easily it integrates with various services, right? Then moving forward, endpoint types. Edge optimized, regional and private endpoints. What does these endpoints types means? So edge optimized means it's for global clients, and whenever we are talking about edges, we are talking about the AWS global infrastructure. I have made a separate video on this global infrastructure, which is very beneficial. So basically, whenever we are talking about edge, we are talking about CloudFront or global accelerator and caching, right? These three things should instantly hit your mind whenever we are talking about edges. So when we are talking about edge locations, basically you can cache your requests using CloudFront edge locations, and it improves the latency, obviously, right? And the API gateway still lives in one region. Obviously your API gateway will not get replicated across your edge locations. Only the data and your requests will get replicated there, so that the latency is less in your edge locations. That is edge optimized. Regional, for clients within the same region. If your application is not global and it is bound to a single region, you can also use a regional optimized or regional endpoint. So, and it can manually combine with CloudFront for more control over caching strategies and distribution. Private means it only be accessible in your particular VPC. It means it is private to your network. Only your subnets and whatever devices or services are in your subnet or your VPC will be able to access this. Simple as that. Alright, now talking about API gateway security, right? How can you secure your endpoints, right? That is very important when it comes to system designing and everything. So user authentication through IAM roles, useful for internal application. If you're having a private endpoint, like we discussed in the last slide, you can control the access to this API gateway by using roles and also by using users, right? Whoever has the permission will be able to access it. Cognito is for external users. So we are going to discuss about Cognito in a separate video, so don't worry about it. And I'm also going to give you an overview of what Cognito in this particular lecture also. So basically it is a authentication tool for external users like mobile users or other website users, your application users. You can authenticate through Cognito. So what Cognito does is basically generates temporary credentials so that users get temporary access. That's it. So you can do that. You can integrate with Cognito. Then there is custom authorization. You can write your own logic also. For example, you are using Spring Boot and you are using Spring Security for your particular authorization and authentication. You can also write the logic using Spring Boot, whatever you want. Custom domain name HTTPS security through integration with AWS Certificate Manager ACM, right? So if you are going for HTTPS instead of HTTP, then you can integrate with AWS Certificate Manager or ACM. Basically ACM is a point where you store your TLS certificates, right? So basically you can integrate with that also. If you are using edge optimized endpoint, then the certificate must be in US H1. That is very, very important point to remember. If you are using an edge optimized endpoint, it means you are using CloudFront Edge distributions, then the certificate must be in US East 1. Okay. If you are using a regional endpoint, the certificate must be in the API Gateway region. Okay. Must set up a CNAME or alias record in Route 53. So in Route 53, you can set up a record or a CNAME record. Alias record is basically it is kind of a CNAME record, but it is used for it is used for AWS services only. Okay, and the difference between CNAME and alias record is that you can only create CNAME records for subdomains. For example, com.example.com or something like, sorry, not com, mobile.example.com. We are going to discuss about Route 53 in a separate video, but just for your idea, this is a subdomain kind of thing, and you can assign a CNAME record to it, right? But you cannot assign a CNAME record to example.com, which is a domain, right? Which is a parent domain, you can just say. But you can assign this particular, parent domain to an alias record or a record. Alias record, you can just say. And your alias record can only be assigned to AWS services. Something like that. If you don't get it, about CNAME and alias record, don't worry. We are going to discuss that in detail in separate video about Route 53. When I'm going to discuss about Route 53, we're going to discuss about it later. But just for your idea, you have to do this for authentication and everything. You can also use custom domain name HTTPS. If you are going to use that, then you have to create an alias record or a CNAME record. Okay, that's cool. Let us move forward. Okay, before going to step functions, let us see an example. Let us see a demo on API gateways. All right. Okay, guys. So I am in my AWS console over here, as you can see, and let us just go to API gateway. Just let me type API gateway. All right. So let us first understand what kind of architecture we are going to create. So let me just open one note and let us try to think what we are going to do or what we are going to do. Let us discuss about it. Now, so basically we are going to create a API gateway, and basically this API gateway will have endpoints. Obviously, for example, there is a root endpoint / and let us create another endpoint / employee, right? So when a request comes in, the request will comes in from the client, right? And there will be two Lambda functions. Let us first start with one Lambda function and let us name it as Lambda 1, and there will be another Lambda function, Lambda 2, right? So if a / endpoint comes in, a / that is a root endpoint and it is a get endpoint, then it will be redirected to this particular Lambda function or Lambda 1 function. And if a / employee kind of endpoint comes in, then it is a post request, for example. So basically this Lambda function will get triggered, right? That is a basic architecture. This is the basic, you can say, architecture, and this is what we are going to do. Pretty simple, right? Let us get on to it and let us do this thing. Let us first start with this Lambda function, and after that we are going to create another Lambda function and we are going to create another endpoint. Alrighty, let's go. So this is the API gateway. So it first asks for choosing an API type. You can create any kind of, you can create an HTTP API, you can create a WebSocket API, you can create a REST API, whatever you want to do, you can do. I'm going to create a REST API. Okay, basically REST APIs are used for microservice based architecture, and then there is a front end framework like React or Angular. Basically then you use it to code your front end part, and this is basically your back end part. That's how microservices architecture are, right? The front end and the back end are kind of isolated from each other, so there is a loose coupling happening, right? You're going to understand this when you're going to learn full stack development. Don't worry about it, we're not going to discuss full stack development right now. Just let us create the REST API right now. So let us click on build. Very easy, guys. Let us go OK. So REST, let us create a new API. All right, and the API, let us name it as test API. Okay, and some descriptions, for example, employee register. We are creating an ERP system, right? And endpoint type, let us keep it as defaults, and let us create the API, right? That's it. That's how easy it is to create the API. Now it is a completely blank API that you are seeing on my screen. So I'm just going to say actions, and I'm going to create a method. So for the slash resource, I'm going to create a get method. So as we discussed, right? So there will be a slash resource and it will be a get method. So for the slash, this is known as a resource in API Gateway. For this resource, I'm going to create a get API, and for this resource, I'm going to create a post API. That's what is going to happen over here, right? So that resource has already been created for the slash or the root one. So I'm just going to create a method that is a get method. You can create multiple methods for the same endpoint, right? That is possible, right? You can do that. You can create for the same root API, root resource, you can create a get method, you can create a post method, you can create a delete method. It is possible. Let us click on OK. So here are the integration types. So let us select the Lambda function, or you can also go for a custom HTTP endpoint. If you have it in the backend, you can create a custom HTTP endpoint. You can create a mock, or you can link it to another AWS service like Amazon MQ, DynamoDB, whatever you want. Let us go for a Lambda function, and currently I don't have a Lambda function, right? And so what I'm going to say, I'm just going to go to Lambda, and I'm just going to open it in a new tab like this. So I'm just going to create, so there is already one Lambda function, let it be. I'm going to create another Lambda function. I'm just going to name it as root Lambda function, because it will be for my root resource, right? Let us select Python 3.8. okay, I already have some codes. I'm selecting that. Whatever you want, you can select. I'm just going to create the function. Okay, let's wait for some seconds. It will take some seconds to create. Let us wait. If you have some tea, take a sip from your tea and have some fun. So this is the function. It is ready. I hope you took a sip of your tea. That's great. So I'm just going to copy this code from here in my Notepad++. Very simple code. I'm just going to copy this here, and I'm just going to paste it over here. And it says hello from Lambda, and I'm just going to say just going to change it to welcome to employee ERP system, right? I'm just going to say this will be the body, right? And the status code is 200. If you are going to learn about status codes, you have to learn about various status. Why am I not pronouncing it right? So status codes like 300, 200, 500, 500 series are all internal server errors and everything. So 200 series are all successful error codes. You can return 200 for success, 201 for resource creation and everything. When you're going to learn about microservice architecture, these will come hand in hand, right? But for now, 200 success code means that if you are returning a 200 success code, then it means that it is a success, right? Simple as that. And I'm going to return some headers, application/JSON. It says that your header content type header means that you are returning some kind of a data type. For example, we are returning a JSON data. If you are returning an XML data, you have to specify here that you are returning an XML data, right? That's it. I'm just going to say test this function, create a new event, some test event. I'm just going to say test event, and I'm just going to say save, and let me just test it now. So okay, so it says response score status score 200, and we are just going to, it says hello from Lambda. Okay, because our new version of the function didn't got deployed, that old version was got deployed. So over here in my Lambda function, I'm just going to say deploy this function. Okay, now it has been deployed. I'm going to test the function. So it says body is welcome to ERP system, right? Now the headers are these things. So our function has been deployed and it has been tested. So we're going to get the body as welcome to ERP system. That's it. That's the only thing we are going to get from our API, sorry, my Lambda function as of now. Right. Now let us go back to our APIs, and here provide the Lambda function name or alias, right? So I'm just going to go over here. Where is it? Okay, this is my function ARN. I'm just going to copy it and I'm going to paste it over here. Great. So this is my Lambda function, and I'm just going to click on save. It says you're about to give API permission to invoke a Lambda function. So let us click on OK, right? And it is going to be saved. Now this is the thing. A request, if you are going to do a request at the slash, and it will be a get request. Integration request is Lambda, right? And then integration response, there will be a HTTPS status pattern, and then method response is 200, and there will be a JSON value returned to it, right? So client will do, and it will go in this particular cycle. And the Lambda function that is being integrated is this particular Lambda function, which is root-lambda-function. Cool stuff, right? If I go over here and if I go to configuration, or I don't know, permissions, I think it should be in permissions. Okay, if I click on this thing, then you can see there is a policy. There is a policy, and the principal is API gateway.amazon.com. And basically what this policy means, that basically it allows API gateway to access this Lambda function. So a policy was created on the background, and this is the policy. If I'm going to view the policy, this is how the policy looks like. So the principal is this one, and the action is invoke the Lambda function, because if our API gateway doesn't have the permission to invoke my Lambda function, then how my Lambda function will be invoked? Always remember, when you are going to when you're integrating multiple AWS services together, you need to make sure that if one service wants to access another service, there must be permissions, and it doesn't come as default. Either it will be created in the background, that particular policy, or you have to do it manually. Okay, so make sure whenever you are integrating multiple services, proper permissions are given. That's what I wanted to show you guys over here. Great. So it is being done. Cool. Now let us go over here, and here it is the stuff, and I'm going to go to actions, and how do I test it? Okay, so this is the thing. So yeah, here is the test button, and I was just searching over everywhere. My bad. Sometimes I miss the common stuff, just miss it. So let us click on test and test the function. So the status request is 200, means that it successfully invoked our Lambda function. If it was not the case, then the status code will not be 200, because we are returning explicitly from our function, we are returning the status code as 200. Latency is 34 milliseconds, which is completely less. And see, this is the response body, and it says welcome to ERP system, and the response headers are something like this, and here are some logs. Okay, so this one has been done, this one has been created, this particular resource has been created, and Lambda function 1 has been created, and this Lambda function 1's name is root Lambda function. Okay, now let us create another one. As I've told you, right, let us create another resource, actions, and create a resource, and I'm just going to name this resource as employee. right? So some details about an employee will be displayed when I'm going to hit this resource. Okay, create the resource, so /employee, and let us click on this /employee. Okay, just a minute, where did I create it? Okay, great. So this is the /employee. Let us go to actions and create a method over here, and let us create a post method. And okay, here integration is lambda function. Let us create a new lambda function now. Let us go back to my lambda console functions, and let us create a function. Let me delete this function, I don't need it. I think in my last lecture I had created it. Always guys remember, even if it is the smallest of smallest things, please remember to just delete your resources. Don't want that particular habit of, you know, keeping your resources like created, right? And if you have a lot of money, then it's fine, but for broke guys like me, it is really important that you just delete whatever you create. Okay, I don't want a very heavy bill. I'll not be able to pay it actually. Okay, let us create the function. So suddenly just our lecture became a lot sad, whatever. So let us name this function as employee. Okay, what employee lambda function, let's name like this. Let's keep it cool. It's not cool, but still trying to make it. Python 3.8. okay, architecture, whatever, create the function. Let's wait for 30 seconds, and you can take a sip of your tea or your coffee, whatever you have, or whatever you have. You can just take a sip. I'm also going to take a sip of my water. All right, so I've taken a sip of my water. Let us move forward, and let us copy the same code that I have over here, and just going to paste this over here. And hello from lambda, instead of that I'm just going to say what I'm going to say is employee name, and I'm just going to say Akash Kumar. It's such a cool name, right? Such a cool name. Yeah. Let's deploy it. Okay, for the sake of it, you can test it. Let us test it. Some event, and save and test. So it's successful. So I'm just getting a employee name as Akash Kumar. That is great. Let us copy this function here in, because I wanted to integrate with this one, right? Just going to paste this over here, and then click on save. Okay, so a policy will get created in the background, so that your API gateway will be able to access your lambda function, your employee lambda function, right? Now let us test this function now, and you can pass in some query strings or something like that, and otherwise just click test over here. So you can see the request to /employee is status code 200 and latency to 32 milliseconds, and the response body is something like this. We are getting this response body over here, right? Cool stuff. Now the thing is, you can deploy this now API. Now you have tested your API. Now the next step is deploy your API, right? So you can go to actions, and you can just click on deploy API, and you can select a new stage of API. So you can just say dev stage, right? As I've told you, right, you can have multiple stages in API gateway. Stage description, I'm just going to keep development stage, right? And whatever, just deploy it. I think our API has been deployed. So this is my invoke URL. I'm just going to go copy this thing, copy link address, open a new tab, and paste it. And let us go with HTTP. So oh, sorry. destroy it again with HTTPS. All right, so you can see now this is my root URL, right? So that is basically, if you are going for the base URL, this is the base URL, so that's my slash URL, and we are getting this welcome to ERP system, right? And if I do a slash employee, I don't think it will work because it's a post API. Okay, you can see that when I'm doing a slash employee, it is saying missing authentication token because it's a post API, right? So that's why it is not working, but it's fine. So this root API is working. So you can use some kind of testing tool like Postman or something to test the post APIs, right? But based on browser, I don't think you will be able to test it just by using your Chrome browser. So, but the thing is that we have successfully deployed our API. It is a slash dev API, right? So slash dev is basically your this is your region name, the stage name, and it is a resource is slash, and it is a get API. That's why get APIs work with browsers. So the slash says welcome to ERP system. So you can see this is the response that I am getting. So yeah, that's how you work with API gateways. Now, as I've already told you, always delete whatever you have created for the particular lesson. I'm just going to select this, and I'm just going to go to actions and delete, and let's click on delete. Go to Lambda functions, go to functions. I don't think I'll be able to delete it right now because it's associated with this API gateway. Oh, it is deleted. Now I can delete it. This actions and delete. Delete. Close. Great. Now let us move to the last section of our series, which is known as step functions. Is it step functions? Oh, it's step functions. All right. Now let us talk about step functions, guys. And step functions is basically building serverless visual workflow to orchestrate your Lambda functions. As the name suggests, it's kind of a algorithm chart for your Lambda functions, right? Like you create, like you know about algorithm charts, right? You go start, then you, for example, you create a variable x equals to 10, then you make a diamond, you just go like this, like this, the x equals to 10, and then you go like a diamond where you just check x greater than 10, and then you go with different directions. This is kind of an example of an algorithm chart. That's what this particular step function means. So if you see this diagram over here, so you start, pass hello world example. This is an example. Yes, wait for 3 seconds, otherwise invoke any Lambda functions, and then end. That's what it means. You can integrate with EC2, ECS, on premises or anything, servers, API gateway, SQS, queues, whatever you want, you can just include in your step function. So step by step, whatever instructions you are going to give, it will get executed. Possibility of implementing human approval feature, right? So that you can create an approver, you can keep an approver in between the steps who can approve, like, okay, you are okay to go to the next step or something like that. Use cases are order fulfillment, data processing, web applications, or any workflow. Order fulfillment, right, it goes through certain steps, right? There is a approver, there is a distributor, it will say, okay, this order is fulfilled, the payment has been processed, and then it happens. Data processing has multiple steps, right? Data cleaning step done, okay, then go to the next step. Data transformation step done, okay, then go to the next step. Data archiving step done, then that is fine, generate the report. That is how you are going to create your steps. You have to visualize it in your mind, right? So we don't have a particular use case right now, so we're not going to go into deep into step functions. So that's it, guys. That was all about our serverless things on AWS. I know I also told you about certain things like SQS, SNS, and some other serverless features, but those are separate topics. Actually, we are going to cover that in a separate video. But for now, you know about SQS, right? I've told you it is a simple queue service, right? And for SNS, it is a notification service. If you want to create push notifications and stuff, you can create it using SNS. But for other serverless features, which are important things like Lambda API Gateway and DynamoDB and stuff, I have covered it in detail in this particular video, and hope you guys like it, and it will definitely help you in your exam. So till then, have a nice day. We are going to meet in our next video. Till then, bye bye.